Hello everyone and welcome to Reconstructing Cave Story. So, what is Cave Story? Cave Story is an action platformer in the vein of Mega Man. You just fire guns, collect experience for your guns, and basically just explore all these really cool environments. It's a game made by Pixel and is off time in 5 years, which is really impressive because he made the art and music and he did the programming. So what this is not a deconstruction of Pixel's code. We're not going to be looking at any of Pixel's code. We're also not going to be generating any art, music, or any assets like that. We are going to be doing a programming walkthrough. This is not we're going to be using the C++ language, but this is not a tutorial on the C++ language or C++ language constructs like smart pointers, for instance. So what this is, it's a journey to reconstruct Cave Story, and it's an intermediate level learning experience for C++ and a look at building a detailed game engine. And why would I want to do this? Well, first of all, full detail game engines are very complex. It's really hard to find good tutorials that really dive deep into the complexities that are video games, because there's so many details that go into making a game engine that's really robust and full and detailed. And I also just want to help people appreciate how awesome Cave Story really is. So what we'll need for this first episode, episode 1, you're going to need STL version 1.2. I'll put a link in the description. For later episodes, we're going to need Boost. I have version 1.48, but I don't think it really matters. I'm also looking into using Gorilla Audio, but I haven't tested it out yet, so we'll see. So, yeah, that's what we'll need. So without further ado, let's look at the next let's look at the first problem. So the first problem is we need to handle input and need a consistent way to update and then draw everything. And we also want to be able to limit FPS, because if FPS gets jumpy, like starts jumping around from like 1,000 frames per second to 500 frames per second, it causes stuttering, which is noticeable to the player, and we want to avoid that. And so we'll probably limit our FPS to about 60 frames per second, and that is to keep it around the refresh rate of most monitors. So I think Pixel did his at 50 frames per second, but I don't really understand why he did that, so we'll just ignore that. So the solution is the event loop, which is what we're going to talk about. So I made, right now, I am in a Cave Story screencast directory where I'm going to be putting all of the Cave Story creation stuff. Right now there's 4 folders. Content is where I'm going to be putting images and music and stuff like that I'm going to just basically take from Cave Story itself. Gen doesn't have anything in it, but that's where we're going to be putting the actual executable game file. Slides, that's stuff that I show you. And source is where we're going to be putting the actual code itself. So let's start with the main, because every C++ program needs main. We don't really care about input parameters because we'll care about them later if we need them. So what I'm going to do is I'm going to put everything into a game class, and I haven't built the game class yet, but I'm about to do that, and we're going to put it in game.h. So this is just going to construct the game class. The game class will fire off the event loop, and then once it's done, it'll finish with the constructor and then return 0 and exit, and all will be good. So let's go ahead and look at the game class. so let's start with our header guards. And make a class definition. I like to use struct, but most people like to use class. So we'll go ahead and create a corresponding CC file. And the constructor. I'm also going to want to create a destructor because there's a lot of like SDL, when you initialize it, you also want to make sure that you quit at the end, and so I can put all that kind of stuff in the destructor for game. So alright, so before I get too far into this, I'm gonna make a makefile. So this will be in the top level above the source directory. So I'm gonna make a compile target. I like to use Clang. A lot of people use G++, but I find the errors atrocious, so I like to use Clang. So we're going to make an object file in Gin, and we'll call it Cave Story. And then we're going to basically take this is a really cheap way of compiling, but it's small enough now that we can do this, and then we'll look at making a better makefile later. So this will just grab all the CC files and compile them into Cave Story. I'm also going to make a run target, which is just going to be Gin Cave Story. So I'm going to go ahead and compile. And as we can see, Clang C++, Gin Cave Story, it looks like it worked. So we'll go back to, let's look. So see how I have makefile in the top level directory alongside source and ls source, and we have games and main. So let's go ahead and look at game CC again. What we're going to want to put inside of the initialization is we're going to basically shovel everything into an event loop, or no, this is where we're going to kick off the event loop, and this is going to be an infinitely running loop. So once this gets done, then the constructor will finish, and then it'll return to main, and then main will finish, and then it'll deconstruct game then. Okay, so let's go ahead and add an event loop method. Okay, so how is the event loop going to work? So first of all, we're just going to go while the game is running. And this is going to happen approximately 60 times per second. And we'll consider each iteration of the loop to be a frame. So the first thing we're going to do is handle input. And also, what we're going to be doing is handling events. And events also includes stuff like timer callbacks. I'm still not sure if we're going to be using STL's timer. It's just because I hate callbacks, and I think they're just so horrible to use in C++. So that's why. Actually, I'm just going to get rid of that. Handle input for now. There we go. Okay, and then we're going to update everything. This means move the player, move projectiles, check collisions, and then we're going to draw. And we separate those because we want everything to be all in the same frame before we draw, so it doesn't like create like, oh, the player's moved in this frame, and then we draw the player moved, and then we move the projectile. You know, it just doesn't work. So then we draw everything, and that includes the background and stuff. So now that we have our pseudocode, let's go ahead and code it out. Bool running equals true, so we start out running, of course, running. So now we get to the 60 frames per second. So how do we ensure that it's this only happens, this loop lasts 1/60th of a second. Or you could also say this loop lasts 1,060ths of a millisecond. And that's important because we are going to be using the SDL delay, which takes milliseconds. And we want this to last 1,060ths. And this is going to be milliseconds. This is going to be frames per second. Oops. And that's how long we need to delay in order to get this to last 1/60th of a second. So SDL delay, this means we need SDL. Which means we need to initialize SDL, and I'm going to do this in the constructor, of course, and we'll just init everything. There's a bunch of different combinations of flags you can do for this, but for now we're just going to SDL init everything. And then we also, at the end, in the destructor, we want to SDL quit, and so this will restore everything, all the resources that SDL is using to their rightful state. Okay, so we have the wall running at approximately 60 hertz. Okay, sweet, that's done. Next, we're going to go ahead and do update and draw, because those we're just going to put in little helper functions. Or helper methods, I guess. Okay, so now we have update and draw. I'm going to go ahead and make sure that it's function undefined reference to SDL init. So we also need to update our make file so that we link to the SDL library. And so that looks like it's working. So we update and draw. Oops. Hold on. Sorry about that. So we update and we draw. We also need to handle input. So the way this works is SDL has an SDL poll event, which just has a stack of events that or a queue of events that it's looking at, and it just takes the next one off the queue, and then you can process the event, and then it'll return true if there's another event, or it'll return true if there was an event, and return false if there wasn't. So let's go ahead and let's look at SDL poll event. So returns 1 or true if there are any pending events, or 0 if there are none available. And it gets stored in this SDL event structure that we can pass in. So this is basically where I'm getting my code from. You can look at it in the man pages if you installed the documentation. So let's make an SDL event. Just call it event. And we'll do while SDL poll event, and then passing it as an out parameter, passing the event as an out parameter, and then switch. so this will go ahead and process all the events. So another problem, all of this from here to here all takes time. And so we need to take that time into account and not delay 1,000 over 60 frames, 1,000 milliseconds over 60 frames per second. We need to delay that minus the elapsed time. And the elapsed time is equal to the current time, which is an STL get ticks, which returns the number of milliseconds since STL initialization, minus the start time, and we're gonna need a start time, which is just, of course, STL get ticks. Okay, and so that'll keep everything consistent. Next, let's see. So yeah, I'm gonna go ahead and make. Looks like everything's compiling, so that is beautiful. Let's see, what's one more thing I want to do? This is basically the event loop in a nutshell, but I want to be able to make it so that you can exit by hitting escape. So we'll say case STL, case the event type is STL key down, if event dot key dot keysim dot sim dot equals STLK escape, then we want to do running equals false. That's all we want to do, because that'll finish it off. While running will be false, and then we'll get to the end of this, and then everything will quit. So I'm going to try that. I'm not sure if it'll work without a screen, though. No, it doesn't work without a screen. Okay, hold on. Okay, so we're going to make a quick screen. Forward declare it so that we don't have to include it in the header file. Screen. Okay, so the way to make a screen is to use STL set video mode. And this takes a width, a height, a bits per pixel. We're going to set that to 32, and flags. And for flags, we're only going to look at STL full screen. Okay, so screen equals STL set video mode. So this is creating a new screen, by the way. So we're going to need to free it later, but we'll get there. Set video mode. So width, height, bits per pixel, and flags, STL full screen. So let's free it before we quit. STL free surface screen. And I think it should create a full screen, yeah! And I hit escape and it exits, perfect. Sweet, okay. So, what else do I need to do? I'm gonna make constants, because constant K screen with, a lot of people do, it's either you start it with a K and do camel case, or you can do all caps, but I'm doing the Google style guide of K, camel case, or constants. Bits per pixel equals 32. And so that you guys can see it all. All right. Oh, here's another constant. KF. I'm not really gonna make a milliseconds to seconds constant. I don't really see a need to do that. Let's see, is there anything else? Let's just run it again, make sure everything's working. Sweet, I have a cursor. Actually, let's get rid of the cursor. That's one more thing we can do, and that's it, I promise. So, STL show cursor, and this function either takes STL enable or STL disable, so we want to disable it. Why doesn't it say true, take true or false? I don't know. I don't know. But that's that. So now we have our game loop, and yeah, that's it. Thanks for watching.